Welcome to the Global Issues Daily. Now, human engineering has achieved some truly unbelievable things. We've walked on the moon, we've built skyscrapers that literally pierce the clouds, and we've carved massive transit tunnels right beneath the ocean floor. But even with all of that, the Great Pyramid of Giza still leaves the world's greatest modern engineers completely in awe. It's a structure that has baffled human intellect for 4.5 millennia. So, today, we're taking on a definitive audit. We're going to calculate exactly what it would cost, both logistically and financially, to build a Great Pyramid from scratch in the year 2026. To really grasp the gravity of what we're attempting to audit here, we first have to recognize the immense cultural and historical weight of this monument. As the renowned Egyptian archaeologist Zahi Hawass famously put it, Egypt didn't build the pyramids built Egypt. Think about that. The pure religious motive, the passion, and the unprecedented level of organization required to build these grand tombs for their pharaohs, it quite literally unified an entire civilization. Now, obviously we don't have that same religious motive today, but if we hypothetically had to recreate this exact structure right now and build it strong enough to stand for another 4,000 years, well, we are looking at an incredibly daunting modern challenge. To keep this expliger organized, we're going to break this hypothetical mega project down into 5 distinct phases: securing the ground, cutting the mountain, the logistical nightmare, assembling the giant, and finally, the final bill. Let's dive right into phase 1, securing the ground, which presents a massive foundation challenge. You might intuitively think the hardest part of building a pyramid is stacking the stones, right? Actually, finding ground stable enough to support a literal mountain of rock is an absolute engineering nightmare. Fun fact, the bent pyramid, which was built by Pharaoh Khufu's father, actually suffered a massive structural tilt just because of poor bedrock support. We simply cannot afford that mistake. To put this in perspective, the Burj Khalifa, the tallest building in the world today, has a total weight of about 500,000 tons. That is just 8% of the weight of the Great Pyramid. Our modern pyramid is going to weigh a staggering 6 million tons. That is the equivalent of stacking up 6 million standard sedan cars. Because of that immense weight, our ground preparation logistics have to be flawless. If we buy 13 acres on the Giza Plateau, the very first thing we have to do is run seismic sensors 200 feet deep just to guarantee tectonic stability against earthquakes. Then comes the leveling phase. Today, we'd use GPS-guided bulldozers and precise lasers. Why? Because basic geometry dictates that a mere 1 millimeter leveling error at the base will multiply into a disastrous 14.7 centimeter tilt up at the 147 meter peak. And finally, since we can't just rely on raw bedrock the way the ancients did, we'd have to pour a 4 meter thick reinforced concrete mat. That alone requires 500,000 tons of concrete, which is roughly 1.5 million bags of cement just for the foundation. So when you tally up the land acquisition, the legal permits, those deep geological scans, and that massive concrete foundation, our running total already hits $550 million. And remember, it's going to take us about 3 years just to do this, and we haven't even laid a single pyramid block yet. That brings us to phase 2, cutting the mountain and sourcing the actual stone. Okay, so our foundation is set, but now we face a logistical hurdle that makes even the most seasoned modern engineers sweat. We need 2.3 million stone blocks. If a standard modern stone factory began cutting these blocks today, outputting a very respectable 100 large blocks a day, it would take 63 years to finish. We don't have that kind of time. To meet a modern 5-year project timeline, we have to radically scale up. We'd need an armada of 250 heavy-duty diamond wire saws operating simultaneously inside the quarries. That's a $250 million investment in cutting infrastructure alone. But here's the true bottleneck. Energy. These diamond wire saws are absolute industrial beasts. Running 250 of them continuously will draw roughly 20 megawatts of power every single hour. If you run that over a 5-year period, the sheer amount of electricity we'd need rivals the entire daily electrical consumption of the country of Italy. That's going to cost us an estimated $155 million just in electricity. Then, when you factor in the cost of the raw materials, we're talking hydrated limestone at around $120 per ton, and the highly specialized granite needed for the inner chambers at $40 per ton. Our raw material cost hits a staggering $1 billion. Just to give you some context on that number, the entire construction of the Burj Khalifa in the early 2000s cost $1.5 billion total. We're at $1 billion just for the uncut rocks. Moving on to phase 3, the ultimate logistical nightmare. Transport operations. So we have our stones, but they're sitting hundreds of miles away in a quarry. We now have to initiate what is arguably the largest heavy transport operation in human history, moving 6 million tons of solid rock. The highest quality granite used by the ancients was actually extracted from the Aswan quarry, which is 900 kilometers away from Giza. To replicate this today, we'd have to load these massive blocks onto standard 30-ton heavy-duty trailers and drive them nearly 1,000 kilometers across the country. To keep up with our aggressive 5-year timeline, a truck must arrive at the construction site every 10 minutes. Let that sink in. To make that happen, we need a dedicated fleet of 2,400 heavy-duty trucks. Because the round-trip journey takes 3 to 5 days, at any given moment for 5 straight years, there would be 500 trucks constantly out on the road carrying stone. This massive transport operation alone adds another estimated $200 million to our bill, and that is entirely excluding any potential road destruction taxes. Next up is Phase 4, assembling the giant through vertical construction. The materials are finally arriving, and we have entered by far the most dangerous phase, stacking stones that weigh up to 60 tons to a dizzying height of 147 meters. The physics here are just brutal. For instance, the granite blocks for the King's Chamber roof weigh 80 tons, and your standard construction cranes simply cannot lift that kind of weight to the center of a 230-meter wide base. We would need a network of 10 massive K-roll 10,000 tower cranes, literally some of the largest cranes in the world, and placing these massive blocks with millimeter-perfect precision, so tight you could not even slide a credit card between them, requires a highly specialized workforce of at least 3,000 laborers. This phase adds $700 million to our bill in crane rentals, salaries, and insurance. So after 8 agonizing years of foundation work and stacking, the main structure is finally up. But here's the thing, it doesn't look like the stepped, sandy-colored ruin that we see today. Originally, the Great Pyramid was encased in 115,000 pristine white Tuora limestone blocks, all polished completely flat. It was quite literally a glowing beacon, reflecting the sun across the desert by day and glowing like white light under the moon at night. Restoring this original, beautifully smooth outer casing adds a final $250 million to our material costs. Which finally brings us to Phase 5, the final bill. It's time for our mega project audit. Let's lay all these numbers out on the table. Our itemized ledger reveals a massive accumulation of capital. $550 million for ground prep, $1 billion for raw stones, plus over $400 million for the diamond saws and the electricity to run them, $200 million just to truck the stones across Egypt, $700 million tied up in the world's largest cranes and a specialized workforce, and finally, $250 million for that glowing Terra limestone shell. When the dust finally settles, our audit reveals a staggering price tag of $2.95 billion. For our viewers in South Asia, that translates to roughly 25,000 crore Indian rupees or 82,000 crore Pakistani rupees. And remember, this is a highly conservative estimate. It entirely omits massive hidden costs like import duties, road destruction taxes, and the dedicated 20-megawatt power plant we'd probably have to build on-site just to power those cutting saws. To properly contextualize that $3 billion, let's look at what modern society usually buys for that kind of capital. With $3 billion, we build the Palm Jumeirah artificial islands in Dubai, we build the ultramodern Sophie Stadium in the United States, we build massive, complex natural gas processing plants in Qatar. Sinking $3 billion into a monument that produces absolutely zero infrastructural or economic output simply defies all modern economic logic. Which leaves us with the ultimate, lingering question. Recreating the Great Pyramid today demands GPS satellites, the world's largest cranes, industrial diamond wire saws, $3 billion, and a fleet of thousands of trucks. If recreating the structure pushes the absolute limits of our modern, globalized industrial capability, how on earth did the ancient Egyptians achieve this flawless perfection 4,500 years ago using only bronze tools, ropes, and human willpower? It is a reality that still sends shivers down the spine of modern engineers. If you found this explainer insightful, be sure to like this deep dive, subscribe to the Global Issues Daily, and join us next time as we continue to unravel the world's most complex topics.